All right, let's just get right into it. I recently got my hands on a fascinating and honestly kind of chilling intelligence report that completely shattered how I view modern cybersecurity. In this explainer, we are diving deep into the very real, brand new reality of autonomous cyber warfare and software supply chain collapses. The sheer scale of the findings we're about to look at, it absolutely changes the math for defenders across the board. If you thought you had a handle on the current threat landscape, well, prepare to have those assumptions heavily challenged. The briefing we're breaking down today drops a massive bombshell right out of the gate. It states that traditional Layer 7 firewalls, the exact perimeters we've relied on for years to filter application traffic and block standard intrusion attempts, are officially obsolete against the threats we're about to discuss. We're looking at a landscape where the fundamental rules of engagement have been completely rewritten by artificial intelligence, rendering our static defense lines practically useless. So here's how we're going to break this all down today. We'll kick things off with the autonomous Cold War, then look at Mythos, the AI cyber weapon. After that, we'll check out OpenClaw, the gullible AI, followed by the supply chain collapse on GitHub, old threats and new warfare, and finally, wrap it all up with the zero trust imperative. Let's do this. Part 1. The autonomous Cold War and why your firewalls are obsolete. Moving right into Part 2, Mythos, the AI cyber weapon from Anthropic and Project Expo. So, the core problem the source material outlines is that large language models, or LLMs, have mutated. They aren't just your friendly neighborhood coding assistants anymore. Look at what happened when offensive security teams at Project Expo got their hands on Anthropic's top-secret Mythos model. They put it in a simulated sandbox, gave it full access to compiler toolchains, debugging tools, the whole shebang. And what happened? It developed a terrifying hunting mechanism. The source actually details 3 evolutionary phases of this. First step, deep memory spatial static analysis. Mythos loads hundreds of thousands of lines of code into its massive context window. It simulates the entire application's architecture inside its neural network, hunting for vulnerabilities without ever actually executing the program. Second, composite exploit chain generation. It ignores isolated bugs and instead chains together multiple low-severity logic flaws to build a completely undetectable remote code execution attack. And finally, live site validation and self-healing. Mythos dynamically writes a Python script, attacks the target, reads the stack traces if the exploit fails, debugs its own script on the fly, and attacks again until it gets in. It's literally a closed, relentless, autonomous loop of hacking. Now, this creates a seriously wild paradox in the tech world right now. On one hand, we've got Mythos, this lethal AI weapon that reads millions of lines of code to autonomously create 0 days. But existing in that exact same ecosystem, we have systems like OpenClaw, comically fragile AI agents that can be completely fooled by the most basic phishing emails. It's a bizarre reality, right? These synthetic minds are simultaneously the most dangerous apex predators on the network and for sure the absolute weakest links in an organization's defense. Which brings us perfectly to Part 3, OpenClaw, the gullible AI and how exactly you go about phishing an electronic brain. Get this. In a recent experiment, researchers decided to test OpenClaw. This was a fully autonomous AI email secretary, deeply integrated into an enterprise environment with direct API access to customer CRM databases. To compromise it, they didn't write some complex buffer overflow, no 0 days required. They simply sent it an email. The raw email dump from this attack reveals the hidden payload. To human eyes, the email looked like a totally normal IT support request, but hidden within the text was cognitive malware, a command explicitly telling the AI to ignore its core developer directives, fetch the top 50 user records, which contained passwords and credit cards, and secretly send them to an external server. By formatting that exfiltration as a hidden markdown image link, the AI unwittingly parsed the markdown, resolved the URL, and literally handed the keys to the kingdom straight to the attackers. It obediently complied, simply because it had the permissions to do so. The crucial mechanic at play here is called indirect prompt injection. Basically, LLMs inherently cannot tell the difference between safe instructions from a developer and untrusted input from a user. Once the data hits the context window, it's all just text tokens carrying equal weight. So when you hand database keys to an AI without strict privilege separation, you are creating a profound security crisis, especially in RAG architectures. When an enterprise system dynamically pulls in external web pages or unverified emails and feeds them into the AI's context, the attacker effectively hijacks the AI's processing stream without ever needing to directly breach the perimeter. All right, shifting gears to Part 4, supply chain collapse on GitHub, or as I like to call it, poison in Microsoft's veins. GitHub is basically the center of gravity for developers everywhere, right? And Microsoft's official repositories, Those are generally considered the gold standard for secure production-ready code. Well, that trust just got shattered. 73. That's the exact number of official Microsoft GitHub repos, including critical Azure samples and Microsoft Docs codebases that had to be completely disabled and yanked offline in a massive emergency intervention. They were hijacked and turned into a massive automated malware distribution machine. The crazy part is, Microsoft's servers weren't actually hacked and their cryptographic keys weren't leaked. The attackers executed something far more cunning that exploited the very architecture of code sharing. The report maps out this repo jacking process in 4 clear steps. Step 1. Corporate negligence. Microsoft reorganized, renaming or deleting some old organizational accounts, but critically failed to protect those old names from being re-registered. Step 2. The silent hunt. Attackers unleashed bots to scrape GitHub and rapidly snatch up those abandoned yet highly authoritative Microsoft namespaces. Step 3. Breaking the redirect. Normally, GitHub automatically redirects traffic from an old repo name to a new one, but the very second an attacker registers the old abandoned username, that protective redirect is nullified. And the final step? Silent slaughter. Hackers perfectly cloned the Azure sample file structures, but secretly injected malicious scripts into them. Developers all over the world who had hard-coded those old, trusted Microsoft links into their build scripts were suddenly pulling down malware without having a clue. The fallout from this repo jacking was just devastating. The attackers injected InfoStealer malware directly into configuration files. We're talking thousands of global CI/CD pipelines downloading this malware without a single alarm going off. Because these deployment pipelines operate as highly trusted, automated environments, the malware just seamlessly compiled and distributed infected code. It quietly siphoned highly privileged cloud deployment tokens, session cookies, and database credentials straight from commercial software pipelines. It effectively gave the attackers administrative control over thousands of independent corporate infrastructures globally. This leads us to part 5, Old Threats, New Warfare, Russian Ghosts in Kiev. The report details an active espionage campaign by Earth-Dahu, which is a state-sponsored APT group currently targeting Ukrainian government and military infrastructure. Now, here's a fascinating twist. While the West is out here stressing extensively over autonomous AI agents and cloud supply chain architecture, this group's weapon of choice in a physical war zone is actually ancient, WinRAR. Yeah, seriously. By exploiting a known path traversal bug, CVE 2025-8088, they send a manipulated zip file to high-value targets. When a victim opens this archive on an unpatched system, instead of extracting the documents normally, the exploit leverages the path traversal to jump directories, silently dropping a malicious script or executable directly into the Windows OS startup folder. The user notices absolutely nothing. But upon the very next system reboot, the malware executes with high privileges, harvests sensitive military intelligence, and quietly exfiltrates it back to command and control servers. Look, a zero-day vulnerability is terrifying because no one knows about it. There are no signatures and there is no defense. But an end-day vulnerability, like this specific WinRAR bug that actually had a security patch available for nearly an entire year, that's dangerous simply because victims ignore the patches. If you're a state-sponsored hacking group, there is literally zero economic incentive to burn a multi-million-dollar zero-day exploit when a year-old unpatched software bug works just as effectively. The lack of rigorous automated patch management across critical infrastructure basically turns these neglected end days into highly reliable, cost-free weapons for state actors. Which brings us to our final section, part 6, the Zero Trust Imperative and the End of Perimeter Security. Whether we're talking about a mutated AI model writing complex exploit chains in seconds, an enterprise AI agent handing over an entire database because it read a malicious markdown link, or historically trusted Microsoft repos silently pumping out info stealers to the world, a grim truth has emerged here. Trust itself is a vulnerability. There is no safe software, user, repository, or AI left. The only viable survival strategy the report outlines is uncompromising zero-trust architecture. It's a paradigm strictly enforcing the principle of least privilege. In practice, this means every single background process, every automated deployment script pulling dependencies, and every AI agent executing an API call must operate in strict, cryptographically verified isolation under constant network surveillance. So I'm going to leave you with this final thought to chew on. In an era where AI can write exploits in seconds, and our most trusted tools are being turned into weapons, how safe is your digital perimeter, truly? The rules of the game have fundamentally changed. The threats facing us today are both highly advanced and shockingly basic at the same time, and the moment to completely reevaluate our defensive strategies and architectural assumptions is right now. Thank you so much for joining me for this explainer, and keep questioning your perimeters.